Hello, ladies and gentlemen. Today we're going to be talking about multiplicity. Okay, what that means and what we're going to solve for that and how we're going to use that when we're going to be graphing polynomials in the future. Okay, so what is multiplicity? What are we talking about? So multiplicity is how many times a root repeats. Okay, how many times it repeats. So for an example, I gave a factored polynomial here. So we have x minus 2 times x plus 5 squared times x minus 3 to the 7th. X equals 2, that root would have a multiplicity of 1 because it only shows up once in our function. X equals negative 5 would have a multiplicity of 2 because it shows up twice. The factor appears twice because we have the squared there, so that root's going to show up twice. That has a multiplicity of 2. X equals 3 has a multiplicity of 7 because it has an exponent of 7. It's going to show up 7 times. Why do we care? What's the point of knowing about the multiplicity? Well, it's actually going to help us when we start to graph our polynomial functions here in the future. There's two different things that can happen. You're either going to get an even power for your multiplicity, an even number, or you're going to have an odd multiplicity. If you have an even multiplicity, your graph is going to do what I like to call a bounce at that x-intercept, meaning if this is your xy axis, your graph's going to hit wherever that root is, and instead of going through to the other side, it's going to bounce off and stay positive. If you have a multiplicity that is odd, your graph is going to go through. So it's going to go to that root, wherever that x-intercept is, and it's going to cross over to the other side. Okay, even multiplicities are going to bounce. Odd multiplicities, it will go through at that root. Here's an example of what that kind of looks like. Here's a graph. Okay, so let's take a look at what we're looking at here. I see 3 different examples of roots that I have. Okay, this one right here would be an odd root. And the reason why that one is odd is because we can see our function goes through to the other side. This one would be an even root. Our function is bouncing at that point and staying on the side that it's on. And this one would be an odd root. It's going through to the other side. Here's an example of what you would need to do if you have a function. I would ask you, hey, take this function and find for me all the factors and the roots and tell me what their multiplicity is, okay? Now this one's kind of set up where I can just factor this quadratic. So we're going to say that g of x is going to be equal to 3x. And then this quadratic is going to factor into x plus 3 times x plus 3. You could write that as x plus 3 squared as well. And so when I'm listing my roots, I have 2 roots. I have a root of x equals 0 and a root of x equals negative 3. Again, I'm getting that by setting x plus 3 equals 0 and solving. Now that's what my roots are. What's my multiplicity? Well, it's how many times these roots show up. I have one factor that's giving me the root x equals 0. So this one would have a multiplicity of 1. The negative 3, I have 2 different factors that are giving me negative 3 as their root. So this one I have a multiplicity of 2. So I know generally what this function is going to be doing at these 2 points when I go to look at its graph. At this point, it's going to be going through at 0, and it's going to be bouncing at negative 3. Okay? So that's multiplicity. That's what we need to talk about today. Thank you all for watching.